Every form of life depends on thousands of different molecular machines. Molecular machines that enable and speed up biochemical reactions that help us digest food and produce energy for our bodies. Without them, it would be altogether impossible to exist. These molecular machines are better known as enzymes. And they are not just crucial in living organisms. Nowadays, enzymes are also used for all sorts of products and processes. Certain medicines, biofuels, beers and soft drinks couldn't be produced without them.
During the making of these products, the necessary biochemical reactions are reliant on enzymes. In fact, each biochemical process requires a very specific enzyme and only works with that exact one. Crucially for product developers, there are scientific techniques in place for studying enzymes at molecular level. This makes it possible to identify enzymes that can be used for industrial processes. Finding the enzyme with the right activity does not always suffice. Products are usually made in factories at high temperatures or in other harsh conditions, while enzymes, having themselves evolved in a natural environment, often do not tolerate these conditions. In order to overcome this issue, changes would have to be made to the structure of enzymes. What you are seeing here is an artist changing the structure of a large enzyme sculpture. It seemed impossible for many years, but scientists have recently succeeded in doing the same with real enzymes, changing their structure, creating more robust and more specific enzymes, and speeding up their reactions. This is what we call enzyme engineering.
Enzymes are proteins and are typically composed of a few hundred amino acids. These amino acids contain an average of around 20 atoms each. A specific enzyme's unique 3D structure is therefore highly complex, as it is built up of thousands of precisely positioned atoms. The power of an enzyme lies in the exact shape or form of its structure. Through enzyme engineering, we can change these structures at atomic level in order to help them adapt to a certain environment or to improve their catalytic performance.
But even with the current knowledge and techniques available, turning an existing enzyme into a well-oiled machine that is perfectly suited to industrial processes is still a major challenge. This is the challenge that is taken up by the Robox project. With its interdisciplinary team of 19 European partners, Robox brings together a unique combination of top experts and facilities that go from identifying and engineering an enzyme to producing, testing and applying it within an industrial process. The project particularly focuses on engineering robust enzymes that can be used in oxidation processes.
Oxidative enzymes use oxygen to perform chemical reactions and have already proven to be valuable for the production of antibiotics. These very selective enzymes can replace other chemical processes that the industry uses now, thereby lowering the need for hazardous materials, precious metals and toxic chemicals.
At the moment, there are only a few oxidative enzymes available for industrial use. Robox is dedicated towards expanding the use of these rare but powerful enzymes, opening doors to improved industrial processes and the development of pharmaceuticals and nutritional ingredients, as well as new and stronger materials. If we create the right robust enzymes, these tiny and efficient molecular machines have the power to change the landscape of today's industry.